with the next topic, isometric view. Isometric view or projection is a method for visually representing three-dimensional object in two-dimensional in technical and engineering drawing. For example, this is the two-dimensional object or two-dimensional view to represent in a three-dimensional but on the 2D plane. That is, on the paper we can show it in this manner. This type of drawing is known as an isometric projection. To understand the isometric projection, we must understand this diagram. Here, this diagram shows the isometric projection of a cube. In isometric projection, the three edges which are meeting at a single vertex, they are making an angle of 120 degree to each other. If it is making in this manner, then it is known as an isometric projection. In this manner, it is found that these two edges are making an angle of 30 degree with the horizontal, and the third one, that is height, is making an angle of 90 degree. Let's say the size of this cube is 50 mm. One of the side is 50 mm. If this AB is equal to 50 mm, then and all the edges are 50 mm, then this diagram is known as isometric view. But if it is not a true length but is on the isometric scale, then it is known as a isometric projection. So let's understand first what is meant by isometric scale. Isometric scale is drawn at an angle of 30 degree, while actual length is drawn at an angle of 45 degree. About this isometric scale, we have seen it in an isometric projection in a previous diagram. Now here, if we mark the actual length on this 45 degree line and take the vertical distances from those points till it touches the isometric length, whatever the reduction in this length, these are known as an isometric scale. Mathematically, if we take the ratio of AB by AC, that is AB by this true length, it will be equal to cos of 45, that is 1 by under root of 2. And if we take the ratio of AB by AD, that is this horizontal line and this isometric length, we will get cos of 30, that is equal to under root of 3 by 2. If we take the division of these two values, that is AB by AC divided by AB by AD, you will find that AB will get cancelled and you will get AD by AC on the left hand side here. While on the other side here, 1 by under root of 2 divided by under root of 3 by 2, you will get the value as 0.81. So from here you can say that AD is equal to 0.81 into AC, that is this AD is equal to 0.81 times of this AC, that is the reduced length. Hence this is known as a isometric length and this is known as a actual length. So isometric length is the reduced one as it is drawn at the angle of 30 degree and it is reduced by the value 0.81. Here we are going to learn isometric view. That means we are going to take the true length but at an angle of 30 degree. If we are taking true length at an angle of 30 degree, then it is known as an isometric view. And if we are taking the reduced length on this 30 degree angle, then it is known as an isometric projection. So basically we are going to take the true length on this isometric length or at an angle of 30 degree. Hence what we are drawing is actually a isometric view. Let's take a simple example. Here you can see these are the two different diagrams. This is the top view and here is the front view and this is the top view, as we are going to see it in a first angle method. The first thing we should do is that find the maximum length, height and width. This example or this type of problem is exactly opposite of isometric projection. In isometric projection, from the three-dimensional view, we are drawing the front view, top view and side view. But here, from this type of orthographic projection, we are drawing the isometric views, or we can say it as in a three-dimensional view. Hence again, same here, find the maximum length, width and height. In a front view, this is the length, this is the height and this distance is the width. So here in this diagram, the length is 70 mm, height is 20 plus 20 plus 20 as 60 mm and width is 40 mm. Sorry for the mistake here. Orthographic projection and isometric projection are exactly opposite to each other. In orthographic projection, we are drawing from three-dimensional view into the two-dimensional view, while in isometric projection, we are drawing from two-dimensional view into the three-dimensional view. In orthographic projection, we are supposed to find first maximum length, width and height. Similarly, here also we are supposed to find maximum length, width and height so that we can draw the isometric view. Now let's start with the simple example. First, we are supposed to find what the views in this diagram. As we are solving the numerical by first angle method, the diagram shown here, this part is the front view and this part is the top view. Now in front view, we know that length and height is visible. So this is the length and this is the height. So length is 70 mm and height is 60 mm. 20, 20 plus 20. While in top view, width and length are visible. So here length is this one, 50. It is already given here as 70 and this part is the half one. So maximum is 70. So length is 70 and width is 40. Sorry for the printing mistake. So here the width is 40 mm. So let's start. First, draw the horizontal line. Mark the point O here. Draw the three lines, two of which are at an angle of 30 degree and one will be the vertical to it. So this point is O. It is easy to mark the height, that is along the vertical line. So along the vertical line, which we are supposed to mark the height, that is 60 mm. But where should we mark the length and width? On the left side or the right side? Search for the origin point in the question. Here you can see that here is the origin point. Sometimes the origin point can be on the other side also. Here is our origin point and length is towards the left side from this origin point. So as here is the origin point, mark the length towards the left. As we have marked the height here, here is our length. The remaining distance, that is width, will be on the other side, that is on the right side. If the origin point is here and in the top view it is here, length is towards the right side from the origin point. So in that case, from O, the length should be marked on this side and width will be on the left side. Now complete the box. As here is the length, here is our height, here is our width. From this other point, mark the height and join the top. Similarly on this side, mark the height and join the top. Again from this side, mark the same distance as the width parallel to this line 30 degree. Also, and then last join this point so as to complete the box. Instead of front view and top view, if front view and side views are given, then how to find the length, width and height? So in the front view, we know that this is length, here is the height, and in side view, this is the width and this is the height. Find the origin again. This is the origin point here. As from O, the length is towards the right side. So length will be towards the right side. And width here towards the left side. So width should be towards the left side. Let's see in the other way. If this is the right view and right hand side view, and this is the front view, then again O for width, it is towards the right side from the O. So towards the right side is the width. For front view, this is the length. So length is towards the left side from the O. So this should be the length. In our example, this is the front view and here is the top view. So where the length is, that side, from that side you can see the front view. So here you can see this, from this red part is the front view. Here the top view, and the remaining one is the right hand side view, as it is going to seem from the right side. So here front view is visible from this side, and in front view we can see that it is kind of look like a steps, while in a top view we see that all these stepped point, this from this and this, they are extruded along the width. So let's draw first the front view on this front view side. So you can see that this height is 60. So draw the 60 mm here. Then again 30 mm, this same 30 mm. Then along the height towards downward direction 20 mm. Then here you can see that this is 70 mm. So draw the 70 mm line. Again height wise 20 mm. This distance is you can find from this top view, as this total is 50 mm, so the remaining is 20 mm. So this distance is 20 mm. Again, as this is 30 mm, this is 20 mm, this distance will be 20 mm. So draw this again 20 mm. Now if we observe the question, this stepped front view is extruded along the width and it is seen in the top view. So extrude this along the width. So draw from all these points, draw the line width-wise of the length equal to 40 mm, and then join all the other endpoints. You can see simply the steps. At the end, draw your object by dark line or continuous thick line and give the overall dimensions only: 70 mm, 60 mm, 40 mm. So here is the object in a three-dimensional view. Before going to the second numerical, let's start the isocircle. That means if the circle is there in a two-dimensional view, it won't be visible as it is, that is in in three-dimensional view it won't look like a circle, instead it will look like an ellipse. So how to draw that ellipse in a three-dimensional view? So let's say here is a circle of diameter 50 mm. If we draw a square of 50 by 50 mm, we can easily fix this circle of diameter 50 mm inside it. To draw it in a isometric view, draw the square in isometric view of that distance 50 mm. If we want that circle to be in a top view, draw the square in a top view. If we want it to be left hand side view, then draw the square in a left hand side view. Similarly, if we want that circle in a right hand side view, draw the square in a right hand side view. The process in all these views will be same. First thing, locate the minor diagonal. Here in top view, this AB is the minor diagonal, while in this left hand side view, this AB is the minor diagonal. In right hand side view, this will be the minor diagonal. The other diagonal, this is the longest diagonal. Here also you can see this is the longest diagonal. This is the longest diagonal. Now mark the midpoint of all the sides of the isometric square. 1, 2, 3, 4. Similarly, you can draw it in a left hand side view or in a right hand side view, in whichever view you want the circle. Now here is the main step. Join this minor diagonal point to the opposite midpoints. So for point A, the opposite midpoints are 4 and 3. Join these two. For this B, the opposite midpoint is 1 and 2. Join this 1, B and B 2. Similarly here also for A, opposite point is 4 and 3. So join 4A, join A4 and A3. For B, the opposite midpoints are 1 and 2, B1 and B2. Here also similarly A3, A4 and B1, B2. Now mark these 4 points. First one, these minor diagonal points A, B and the intersection points. This A4 and B1, the intersection point is C. B2 and A3, the intersection point is D. Similarly, here also C, D, this C and D. Now, with A as a center and A4 as radius, that is the distance till the midpoint, draw a arc. Similarly, on the other side, other point, that is B as a center, B2 as a radius, that is the distance of this point to the opposite midpoint as a radius, draw a arc. Let's see it in a left hand side view again. With A as a center and the distance till the opposite midpoint, that is A4, draw a arc. With B as a center and distance till the opposite midpoint, that is B2, draw a arc. Now take C as a center and again the opposite midpoint or the distance till the midpoint, mark as a radius, mark a arc. D as a center, distance till the midpoint as radius, that is D2, mark a arc. Let's see it again in a left hand side view. C as a center and distance till the midpoint as a radius, mark a arc. D as a center, distance till the midpoint as a radius, mark a arc. So here we have completed the ellipse by using all these 4 centers, that is A, B, C and D. Hence this method is known as a 4-point center method or 4-center method. So in this way we can draw the circle in a top view, circle in left hand side view and circle in a right hand side view. Let's say if we want the semicircle, then we have to use this method, which is actually a part of the previous 4-center method. Now here we have just seen that how to draw a circle in top view, side view and right hand side view. If we observe the diagram, we can see that the radiuses which we have just taken to draw these arcs, this distance is actually perpendicular to this edge. Similarly, here also this is perpendicular to this edge. This is perpendicular to this one and this is again perpendicular to this one. So these are actual perpendiculars. So by observing this, let's start or let's see how to draw semicircle in an isometric view. Let's say we want the this semicircle in an isometric view. So complete the rectangle 1, A, this 2, B and 3. This is the semicircle. The end point is 1, this end point is 3, this point is A and this is B and the center is as 2. So in isometric view, if we want to be on this side, we can draw that rectangle here. 1, A, B and 3 and the midpoint as 2. Similarly, if we want it in the left hand side view but in the downward direction, then 1, A, B, 3 and midpoint 2. If we want right hand side view and again the semicircle on the downward direction, then 1, A, 2, B, 3. If we want that circle to be on this side like this, then 1, B, 1A, B and 3. It will be like this. So this is 1, A, this midpoint 2, here is B and the last one is 3. So depends on which side you want that semicircle. Based on it, draw the rectangle. Now from point 1, draw the perpendicular to this A1. You actually found here it will be meeting at this other corner point. Again from 2, draw the perpendicular, actual perpendicular to the AB from point 2. Similarly from point 3, draw the actual perpendicular to this B3. You can see it in a left hand side view again. From 1, draw the perpendicular, actual perpendicular to A1. From 2, actual perpendicular to this AB, and from 3, actual perpendicular to this B3. Here also you can see the same thing. From 1, actual perpendicular to this A1. From 2, actual perpendicular to the AB, and from 3, actual perpendicular to this B3. Now mark this point, this intersection point as well as this intersection point. Here also you can see that this intersection point and this one. Here also this and this one. Now with this point as a center and from this point the distance till it touches the perpendicular point, draw a arc with this. Again similarly, now this point as a center and the distance till it touches the perpendicular point as radius, draw a arc. Let's see it again in a right hand side view. With 4 as a center, distance till the perpendicular as radius, mark a arc. With this point as a center, distance till the perpendicular point as radius, draw a arc. In this way you can draw the semicircle. Follow the same process wherever you want the semicircle. Similarly, you can go for the quarter circle. Just find these 2 points and draw the perpendiculars wherever they will intersect. With that point as a center and distance till the midpoint, mark a arc. Or if your semicircle is on this side, repeat the process. Draw the actual perpendiculars from the corner points. With this point as a center, the distance till the perpendicular as a radius, mark a arc. Let's start with another numerical. Here again front view and top view is given. Find the maximum length, width and height. Here the maximum length is given as 100, height is given as 50 mm and width is given as again 50 mm. So draw the horizontal line, mark the point O and draw 30-degree angle on both sides of that point O as well as the vertical line from that point O. Here this is the origin point given. Length is towards the right side, hence from O length is towards the right side. So mark the length on right side. Height is again vertical, so this is the height and the remaining one is a width. Complete the box based on the distances. Here we can simplify this problem. Instead of taking this slot and this rib, consider this as a simply L. This L, we can see that in a top view again it is extruded widthwise. So first draw that L with by using these distances. So length is 100 mm, height is given as 50 mm, then again top of the L is as 30 mm. On this side the height is 20 mm, here you can see that 20 mm. Now we are supposed to find this distance. So this total distance is given as 100 mm, this is given as 30 mm, hence this will be the 70 mm. So from here mark 70 mm and simply join this height. Now here it is seen that this L is extruded along the width. We can observe it from the top view. So extend it towards the width and complete the L. Now let's see how to draw this semicircle. We have seen that we can observe here that semicircle is of the radius 15 mm. So this A1 is 15 mm, AB is 30 mm and B3 is 15 mm. So simply draw this rectangle at the given position. This is at the top. So here it should be drawn over here. So this should be 15 mm, this should be 30 mm and this B3 should be the 15 mm. Also mark the midpoint as 2. Now from point number 1 and 1, 2 and 3, draw the actual perpendiculars to these lines A1, A2 and B3 respectively. From 1 actual perpendicular to A1, from 2 actual perpendicular to AB and from 3 actual perpendicular to B3. Now you have found the centers, that is 4 and 5. Now with 4 as a center, distance till the perpendicular as radius, draw a arc. Similarly, from 5 as a center, distance till the perpendicular as radius, draw a arc. In this way, we can draw the from this semicircular slot, there should be the edge which you can see, which is on the back side, which is along the height. Here you can see that semicircular hole is along the height. So from this corner, if we draw a line, that line will be easily visible. So draw that line. The line below it is not visible due to this front portion. So you should not draw that. But this part will be visible. From the question, it is seen that the object is symmetric in a top view. So draw the symmetric line in the top view. This symmetric line will actually help us to draw this rib. Now this rib is actually of width 10 mm, that is 10 mm above the symmetric line, 10 mm below the symmetric line. Also this rib is starting from this height 20 mm and touching to this top. So first draw this symmetric line about the 20 mm and to this top 30 mm. From the top view, it is seen that it is 5 mm above the line, 5 mm below the line, that is 5 mm on the either side of the symmetric line. So mark 5 mm on this side and 5 mm on this side. Similarly, here also 5 mm on this side, 5 mm on this side. Simply join these points and complete the. Again here, these edges will be visible. So you are supposed to draw these edges by joining the line. So from here draw the vertical line and from here draw the line along the length. Again, the edges, these edges will not be visible, as this edge will be on the back side of the rib. So remove that. So here you can see you are supposed to remove the edge which is on the back side of the rib. Now let's move to this slot. In this slot, this distance is given, that is base distance is 30 mm. The top distance is not given. Instead, the inclination angle is given as 45 degree. In isometric view, the angles will not be same, that you can't draw this 45 degree directly over here. So instead, you are supposed to find this top distance by using trigonometry, or you can use simply by drawing this diagram in a two-dimensional view and measure the distances. Like here, draw this 30 mm distance, mark angle of 45 degree on both the side and join this. If we measure here, we can find that this distance is equal to 50 mm. So now here we can find that this distance is 30 mm and this top distance is 50 mm, and the distance between these two lines are 10 mm. So by using that, first from this origin point this distance is 20 mm. So mark the distance of 20 mm, and further then it is 30 mm. So mark the distance of 30 mm. From this 30 mm point, basically you are supposed to draw a 45 degree, but as we have just I have just explained that you can't mark the angle. Instead, take this height as 10 mm from the midpoint. Now from this midpoint, draw the line parallel to this length, and on that line from this midpoint mark 25 mm on this side, 25 mm on that side, other side, and simply join the end points till to this 30 mm end point and complete the slot. Now again this slot is going along the width, so draw the line from these points along the width. If we draw the line from this point along the width, you can see that this is that line. The other line or the further line will not be visible. If we draw the line from here, you will find that that line will be actually behind or below this one, this red line. So you can't again see it directly in an isometric view. So you don't have to draw that line. So only one line will be visible here. At the end, dark the actual edges of the object and give the overall dimension. So here you can see that this is what the L is, and in that L we have created the semicircular slot. Also we have shown the H, and then we have completed the rib which is along the symmetric line. We have shown these edges which are joining that rib to the L, and again we have removed the back edges as they will not be visible due to this rib. Then we have completed this slot. In this slot, again this angle we can't mark directly as 45 degrees, so we have found this top distances, and then we have taken the height from the midpoint, and from the midpoint we have marked the distance on the both side and simply join the end of the top line and the bottom line, that is top of the 50 mm line and bottom line as 30 mm line.